Okay, in this problem we're looking at finding the equation of parabola and the 2 points that define the latus rectum and graph the equation. So the first step is to get the equation of the parabola. So they give us here that the directrix is y equals 1/8. So that is a horizontal line that goes through 1/8 rather. And they also give us the vertex. The vertex is here at 0, 0. So, I'm kind of a visual person, so I'm going to make a little rough sketch of that. So we've got, and that's too rough. Let's see. So we have an X, right, an X and Y axis. And we'll say this is 1 and this is -1 because we're working with some fractions here. Y equals y equals a positive 1/8. So that's going through here. It's a little differently. Oh, it's not a very straight line, but anyway, kind of get the idea. That's the y equals 1/8. Our vertex is sitting here at 0, 0. So we know the focus is the same distance from the vertex to the directrix. So that's 1/8. So the focus has got to be down here. Have a different color. This is our focus. And I'm just going to jot this down somewhere. So our focus is the ordered pair 0, -1/8. Gracious. And then we know by all of that our parabola is going to open downward. Opens away from the directrix and encircles the focus. Okay, so it's looking something like that. Now, to get the equation, since we know the focus is 0, -1/8, and the distance from the vertex to the focus is the value of A. In our little formula, our basic formula is x squared equals -4ay. And the reason we're using the -4a instead of the positive is because our graph is opening downward. So our distance here is 1/8. So I'm going to replace this a here with 1/8 and simplify all of that. So that's the equation. X squared equals -1/2 y. So that's the equation of our parabola. Now, to find the points that define the latus rectum, for this, we're looking at the fact that the distance, let's see if we can do this a little bit different. The distance from the focus, and we're looking at going out horizontally here. This distance is 2 times the value of A. So since this distance is 2A, mark that if I can, not shaking too bad. That puts our point as one of our points, that's the left point, is going to be this -1/4, -1/8. Okay, because the y was -1/8. And if I go 2 to the right to get my other point, that is this point, which is 1/4, -1/8. Now I want to graph this. And if I could expand my graph in such a way, I know when we come over here and look at this grid, it's got everything marked off in integer values. So I do know the vertex is sitting here for my parabola. And when I get ready to draw this, one of my choices is to choose a parabola, click on the vertex first, and then we have to have another point. Well, we can't do this 1/4, -1/8, and -1/4, -1/8. But if I just keep on continuing downward here, I do notice that if x is 2, I tried x as 1. If If I go back here and plug in a 1, then I'm still going to have a fraction for my y. But if I plug in a 2 for x, back in my equation for the parabola, substitute a 2 for x, then my value for y ends up being -8. So that is another point on the graph. Substitute. So that's what I would do, is I would just plug in integer values for x in this equation that you have and find a value for y such that you end up with integers, since that's all you're allowed to graph on this. I hope this helps.